Assalamualaikum and hello to the lecturers and everyone. We are from FLS 120516. For PHY351, we will be presenting to you about the class in electronic devices.
Before we start, let me introduce our team members. My name is Putri Sabrina. My other team member is Nur Amna Najwa, Nur Fazila Tasha, and one is Mahani Shamimi.
Glass is a widely used material in a modern electronic devices. Today, we can find glass in almost every electronic product, such as smartphone, tablet, laptop, and any display panels. Although glass may seem simple and fragile, it plays a very important role in electronics. From a material science perspective, glass is chosen because it provides a high transparency, protection, and also a functional performance. Without glass, modern touch screen and any display technologies would not be possible. Therefore, understanding glass as a material is very important for electronic device development.
For my topic overview, glass is an important material used in electronic device. In material science, glass is valued because it has key properties such as transparency, strength, and a smooth surface. These properties make glass suitable for use in screens and display panels. Glass is also important because it protects internal electronic components while still allowing clear visual display. In real-world applications, glass is widely used in smartphones, tablets, laptops, and television screens. It also enables touchscreen technology, allowing users to interact directly with electronic devices.
I will talk about background and history of glass. Glass has been a part of human history for thousands of years. Earliest was found in Mesopotamia and Egypt in 3rd century. Initially, glass was used primarily for decorative purposes such as beads and also jewelry. By the 20th century, glass production moved into further innovation and rise to functional varieties used in science, medicine, and technology. Today, in the 21st century, advanced functional glass materials like antimicrobial and antibacterial glass are widely used in electronic devices like smartphones and also laptops. These are the application and example. First is the composition. There are two types of glass materials, which is soda lime glass and also high alumina silicate glass. For the soda lime glass, it uses silicon dioxide that contains 70 to 75%, which is basic for glass transparency and hardness. Also, it contains sodium oxide, which is 12 to 15%, and calcium oxide that have 8 to 10%. Sodium oxide acts as fluxing agent, while calcium oxide acts as stabilizer. For example, it used in basic display screen. For the high alumina glass, the composition contains aluminum oxide, which is 12 to 13%, and also have strong mechanical strength that can reduce thermal expansion and prevent glass from cracking under sudden temperature changes. For example, it used in Gorilla Glass for smartphone and tablets. Number 2 for the application and example, which is physical properties. Physical properties are the external manifestation of a material such as hardness, impact resistant, and also light transmitting. It is in 3 types of properties. For the first one is mechanical properties, optical properties, and also thermal properties. First is the mechanical properties. It acts as a cover glass durability with key of being hardness and impact resistant. For example, hardness and scratches from key and coins will not leave a mark on screen. According to the ball drop test, high alumina reach 1.5 meters and more than 1.8 times that soda lime glass have. This is due to higher elastic modulus by high alumina that contains 72 GPa, while soda lime glass have 68 GPa. This explains that higher elastic modulus allow glass to buffer and disperse stress, that reducing risk of breakage. For the second one is optical properties. High alumina glass has a light transmittance of over 91% without obvious color cast. For example, it used in OLED or LCD display, while soda lime glass has a light transmittance of only 88% to 90% and tend to show a slight bluish green. Next is the thermal properties. Soda lime glass has a high coefficient of thermal expansions, which is 95 times 10 power of -7 degree, prone to cracking under drastic temperature, while high alumina glass has a low coefficient of thermal expansion between 40 degree to 85 degree. For example, it used in smartphone screen that prevent glass from peeling off from screen due to temperature fluctuation. Next, the last one for the application and example, which is the third one, is processing technology. It producing using the float process that contain 3 types, which is float soda lime glass cover substrate. Second is float high alumina glass cover substrate, and the third one is overflow high alumina glass cover substrate. The step of the processing technology is molten glass will flow from the furnace into molten tin, where it floats and spreads to form a flat glass ribbon due to gravity and surface tension. After cooling and hardening, the glass is pulled by rollers into an annealing layer. Following annealing and cutting, flat glass products are produced.
Now, I will discuss the latest advance and innovation in glass used for electronic device. First of all, let's look at flexible and bendable glass. These new glass materials can bend without breaking. As a result, foldable phones and wearable devices can be made. For example, the Samsung Galaxy Z Fold series use this kind of glass. In addition, ultra-thin glass. This glass can now be made extremely thin at the micrometer level. This means device can be lighter, thinner, and easier to carry like modern smartphones and tablets. Moreover, glass with enhanced conductivity. Some glasses include conductive coatings or nanomaterial such as indium tin oxide, which helps improve touchscreens and display performance. Furthermore, transparent and durable glass is stronger scratch resistant and clearly than traditional glass. Consequently, it increases the lifespan of device, such as Gorilla Glass filters used in high-end phones. Finally, smart glass technologies. This smart glass can change its color or opacity, which allows energy-saving application and privacy. For example, like smart windows in buildings and laptop privacy screen use this technology.
To start, let's look at why glass remains the gold standard for electronics despite being such an ancient material. First and foremost, it's about optical precision. Glass offers a level of clarity and color accuracy that plastic simply can't match, which is why your OLED and LCD screens look so vibrant. Beyond aesthetics, it's a functional necessity for touch interfaces. Because glass has a specific dielectric properties, it allows capacitive sensors to track your touch with incredible accuracy. It's also our first line of defense. Its surface hardness protects our expensive hardware from the keys in our pockets and daily wear. From a connectivity standpoint, glass is a silent hero. Unlike metal, it is RF transparent, meaning it doesn't block 5G signals or wireless charging. Finally, its thermal stability ensures that even when your processor runs hot, the screen won't warp or lose its shape. In short, glass isn't just a cover, it's a high-performance component. However, using glass come with a significant engineering trade-offs that we are constantly trying to overcome. The most obvious one is the inherent brittleness. While glass is very hard and hard to scratch, it isn't tough. It doesn't bend or bend, it shatters. This remains the leading cause of device failure globally. We also face a weight challenge. As we push for lighter devices, the density of glass becomes a hurdle compared to lightweight composites. There is also the issue of reflectivity. Without expensive anti-glare coatings, glass acts like a mirror, making it nearly impossible to read your screen in direct sunlight. Looking toward the future, flexibility is the new frontier. Creating ultra-thin glass for foldable phones is an incredibly complex and expensive process, as the material has to be thin enough to fold but strong enough to survive thousands of cycles. And lastly, there is the repairability factor. Because modern design often bond glass to the frame with permanent adhesives, a single crack often means replacing the entire housing, which is costly for the consumer and creates more electronic waste.
For the future trend, one of the major future trends is the development of a flexible and a foldable glass. This type of glass is designed to bend or fold without breaking, allowing a new design such as foldable and rollable electronic devices. From a material science point of view, this is achieved by reducing the thickness of the glass and improving its flexibility. Flexible glass improve portability and allow manufacturers to create innovative devices designed that were not possible before. Another important trend is the ultra-thin glass, also known as UTG. UTG is much thinner than a conventional glass but still maintain a high transparency and a mechanical strength. This glass is often chemically strengthened to improve durability and also resistant to crack. The use of ultra-thin glass helps reduce the weight and thickness of electronic devices, making them lighter and more comfortable to use. The future glass materials are being developed to have improved resistance to impact a daily wear. These include a better resistance to scratches, drop, and also a pressure. These improvements are achieved through a modification of a glass composition and the application of advanced surface treatment. Stronger glass increase a device lifespan and reliability, reducing the need for a frequent screen replacement. Glass also continues to evolve through a continuous improvement in composition and a material design. Material scientists aim to optimize both mechanical properties such as strength and flexibility and also optical properties such as clarity and light transmission. This allowing the production of customized glass material for a specific electronic application depending on a device requirement. In conclusion, glass is a key material used in electronic devices such as smartphone, laptop, and any display. It has important properties including a transparency, strength, durability, and also a chemical stability which make it ideal for electronic application. Advances in material science have significantly enhanced glass performance, enabling a modern and a future electronic technologies. Therefore, glass will remain a highly significant material in the development of a durability and a high performance. Also, will be a next generational electronic devices.
So here are the references that were used in the making of this presentation slide.
That's all from us. Thank you for watching.